Hi, this is James from iRota, and today we'll be talking about toggle switches. Now, switches are probably one of my most favorite components to work with. Now, the way that I personally use switches are to control signals in my DIY modular synthesizer, but you can use switches to control where you want to send a signal in any circuit, and it's really tactile, which is one of the reasons why I absolutely love them so much, is because it just makes this really great clicking sound. And I always have these like NASA fantasies, like I'm gonna go fly into like the space shuttle, and you flip all the switches and you get ready to go. I find switches really exciting for that reason. Well, and also the fact that you can control your circuits in a very specific way, so you can change different aspects of what you're doing just by a flip of a switch, and sometimes get like very dramatic results from just that one flip. And I find the user experience of that very exciting. It's very visceral. Now is also a good time to mention that everything that I'll be covering in this video will be dealing with small signals, low power stuff. The switches that you'll be seeing and the examples that you'll be seeing, I mean, they're not suitable for high voltage circuits or main power. Okay, so with that out of the way, let's talk about the first type of switches that I think you'll run into. So a Tact switch is a common switch that is used in a lot of electronic projects, and actually is probably what is inside of your computer keyboard right now. So every time you push a key, it closes a circuit and it tells your computer which key that you pressed. Now, the technical term for that would be a single pole momentary switch. And when I talk about poles, I'm talking about how many circuits are closed every time that you press a key. And in this particular case, it's a single pole, and it's momentary because it only closes while your finger is pushed down on the key. Okay, so this is like the super industrial version of a single pole momentary switch, and we call these limit switches. What it does is if something goes past a certain limit, it'll close that switch and probably send a signal to the controlling software for that machinery, and it'll probably cause that machine to like stop. It's a safety type situation, but it's a very basic application of that switch. So this is just a really beefy version of that. Now, there's different variations of these push button switches. You have latching switches, you have switches that are normally closed, so when you push down on it, it actually will open that circuit, so it works in reverse. And you actually have switches that have multiple poles built into them. And what that means is you can actually have multiple circuits with just one single button push. So with that, I want to talk about switches and what you can do with them when you do have multiple poles. Okay, so when I say poles, poles are the number of closed independent circuits within a switch. Now, I know that sounds kind of confusing, so let me show some examples to help you understand what I'm talking about here. Okay, over here we have a dual pole toggle switch, and if I move the toggle switch down, you see the upper LED light up, and when I go ahead and flip that switch again up, you'll notice the LED on the bottom light up. Now is a good time to explain some mechanical aspects of toggle switches, and that is that when you flip the switch up, the terminals on the bottom are what get closed. So it's going to be opposite of which side the toggle is on. And those are two separate circuits within that one throw. So there's an up position and a down position. So we would actually call this a dual pole single throw switch. Now, when I talk about throws are the number of positions a switch is going to have, and it actually kind of relates to how many poles it's going to be closing as well. So in this example, I'm going to use my modular synthesizer to illustrate the point. So I have this switch wired into a sawtooth waveform and a square waveform. And because I have two poles or dual poles on a single throw switch, I can select which waveform I want as an output because there's two circuits within it. One circuit is sending out that sawtooth and the other circuit is sending out that square wave. So with one flick of a switch, I can select between those two sources, and they make another type of switch that actually has three positions. So, but we'll still only have two poles. So there's still only two circuits, but there's three positions that the switch can go in. So it can turn on one pole and then turn off and then turn on another pole, depending on where you flip the switch. So on the top is on, the middle is off, and on the bottom switch is on again. And you know, an example of what I could do with that, again, using my modular synthesizer as an example, is I can use it to control the pitch of my oscillators by feeding voltage into it. So in the top position, it feeds an additional 1 volt to my oscillator to make it pitch up. If I select it to the middle position, it's off, so it's just kind of normal tuning at that point. And if I select the down position, I'm sending it -1 volts to drop it down an octave. So with that three-way switch, I have control of adding an octave. So I've closed one circuit off, so it's completely normal, or down, and then I've actually sent it a negative voltage to bring the octave down. So with those three positions, on, off, and on, I can control the voltage that goes into my oscillators. So now what happens if you start stacking switches together? So essentially you just get multiple switches, kind of glue them together, but it's controlled by that single toggle switch. Now things get kind of interesting because we can start controlling multiple circuits even more so than we could before, just because we have the extra poles to work with. So now that we have the extra circuits to work with, a common application would be an indication of whether the circuit was on or off. So you could wire in an LED to show that it was on, or you could set up the LED on the other side of the switch to say that it was off or bypassed. And this would be like a very common situation with this type of circuit. And of course they make them bigger and bigger and bigger. So you can do quite a bit with just a single toggle switch. Now, this is a fun switch. It's a switch that actually doesn't turn off. It has 3 different circuits built into it. So on the top position, middle position, and bottom position, you get 3 different on circuits, and you can do quite a bit with this. So in this example, I want to create a 3-way selector switch, so I'm going to be able to select an input up to 3 inputs from a single toggle switch. So the first step is to wire in 2 terminals, and at that point what I can do is when the switch is in the down position, I've selected input 1. When it's in the middle position, I've selected input 2, and when it is in the up position, we have input 3. So with a single connection, we've created a 3-to-1 switch. Super cool, right? So I want to show you how to solder in a terminal, and it's actually quite easy. The only thing you really have to worry about is that you're not putting too much heat on that terminal, because you know, the switches, if you get a cheap switch, they can melt really easily. So don't buy cheap switches, first of all. So you want to get in there, make that joint, and get out as fast as possible. I think we're out of time, so I'm gonna have to wrap this guy up. So I'll be doing some more videos very soon. Please like and subscribe, and I'll see you guys next time.